here at Rasa, who some of you might have heard of before, others might not. And so, just to be honest with you, I'm that only by night, by day I'm more of a PhD student at Imperial, but we're not going to talk about that today. So I guess most of you will know that conversation AI will probably change drastically how user interfaces work, so that we don't necessarily have to go through long pages to fill forms, but rather can talk to someone, which hopefully is a bot, because otherwise it's not scalable. So we at Rasa, we build open source machine learning tools that let you build your own chatbot, and for that we basically build two libraries which you can find on GitHub and all those pages where you can find open source software. And basically one of them lets you deal with the language understanding, whereas the other lets you deal with dialog flow and dialog management. So the only question then though is, why only that? We're basically only providing those two bits because we haven't done anything with language generation, which means like we need you to tell the software what it should say rather than it coming up with its own sentences, because this just doesn't work yet. This is open research, we're not there. So basically we're providing those two parts, which we can call the ears and the brain of a chatbot, which is basically the how do we get from a user tells your bot something to what does that thing mean, and then how do we get this meaning plus the things you said earlier into what the bot should do next. And all the connectors, and even you can use speech to text or something to make it work with Alexa or Google Home or a Apple HomePod. No, it doesn't have that yet, I guess. But those things. The question is, why machine learning? Easy bots might look like that when you look at flowcharts. You just start somewhere, you ask a question like, I want to search for concerts, which is this thing, or I want to look for venues for concerts, and the bot directly knows what to do next. The only problem with this though is, I worked on customer projects, which then more look like this, which basically means, oh, your user has a side question which you haven't thought of in the beginning, and you need to add it on in the end, like afterwards, or it just wants to do something like your user might want to do some small talk in between and just ask you how the bot feels like, or what the weather is like, and all those things, and it just becomes really messy to build state machines and those flowcharts. So because of that, we're going to use machine learning, and particularly why Rasa? Rasa is useful compared to bigger toolkits from Google or Facebook and all those things, because it runs locally. You can run it on your own server. You don't have to rely on any other infrastructure provided out there. You keep your own data. You don't have to give all your potentially most valuable training data to a company that might reuse it for their own business cases and just steal that off you. And basically, we're completely hackable because we open source software. You can just take it and adapt it to your own needs, and if there's something missing, just add it on if you have to developers or find someone to do it. So what do we actually do under the hood to make this happen? For the natural language understanding part, as I said before, the goal is to create structured data from text. So, for example, you could have a user say, I have a new address, it's 709 King Street in San Francisco. And what do you actually want to get out of that? This is two things. One is this intent, that is the meaning of something, which says, I want to change my address. So this we're going to call address change. The second thing is, we want to get the entity, which means, what is the, I don't know a better word for that actually. What's this entity you care about in the sentence? Like, it could be an address, it could be an email address, it could be a date, it could be a person, it could be a name of a place, and all those things. So there are two things, as we said, we care about. The intent classification is actually quite simple. Well, for machine learning people, that is. which is we have a sentence which we're going to vectorize into just a list of numbers. For that, there are so-called word vectors out there. Everyone can download them and just turn every word into a number. And then what we actually do is we just average them for a sentence, put algorithm in the end which classifies that, which just says there's a bit of numbers, there's, for example, request weather, there's another bit of numbers means we want to change our address. And that's it, that's magic. Second thing is the entity extraction. That is literally just the how do we get the date or the address. For that, we need to do a little bit more in the pipeline because you need to look at all different possible things within your sentence and then check what is this thing, and then we're going to check is this thing an entity we care about or not. For that, there are already some good libraries out there. We have tools where you can train your own. We have other integrations to just use a library that's already out there that's trained on more data than you will probably collect for an easy chatbot. If you have money, more than enough money, you can just train your own. The second thing is the dialogue handling, as I said. That's called Rasa core for us because it's at the core of the bot. And there, basically, we start with some previous action or state. If you don't have that before, it's basically saying you, oh, I haven't seen anything before. And as soon as the user enters something, we get our intent and entities from our language understanding model at the previous state, which we got from this previous action and everything. And again, just a list of numbers. You concatenate them, have an algorithm which just then predicts what is going to happen next. And same thing, it outputs a statement the bot might say, and when the user has its next input, you just continue the loop until the user says bye or just doesn't talk to you anymore because you said something stupid. So yeah, how do we get started? And that's always a big problem. One easy thing would be, oh, I'm going to talk, I'm going to write stories, and I'm going to try to think of everything the bot might say and the user might say. But we have an easier thing to do that, which is online learning, which basically means you write a really bare-bone structure of your bot. You start with, the user says hi, the bot says hi, you say bye, the bot says bye. And then you're going to talk to the bot and refine it and can add things as you talk to the bot so that it's easier and a more natural way to build your bot. So you say, what's the weather like tomorrow? And the bot says, how do you like it? And then you can say, do I want that? Is it correct behavior or is it something else? And it can basically refine its algorithm as you go along. Next is the interesting part, actually. The idea of that is we're going to build a bot in 5 minutes. Last time I did that, it was 6 minutes. So I hope that works in 5 minutes this time. If my machine actually does something. So yeah, basically, what we have is online we have a starter pack which you can download, clone. It gives you a basic bot functionality, and we can clone that from GitHub, where you then basically get a bot that enables you to which you can talk to, and it does this easy thing like you say hi, the bot says hi, you say bye, the bot says bye, you say thank you, the bot says you're welcome. So I actually cloned that before just to make it easier. And then your thing looks like that. Is that big enough? Can you see everything? Yes? So basically what we have is the stories file, some data for we say hi, you can have different ways of saying hi, and the domain file, which basically is everything the bot knows about. This is the entities, the actions, the intents, all those different things. So currently the bot only knows how to say those basic things, and we want to add the functionality of saving a new email address into some database. To do that, we need to start adding some stories, which basically say, like, if you say, I want to change my email address, the bot should ask you, what is your email address? So we call the story the change email story. And then we're going to say this intent, what the user starts with, is basically just change email. And what happens next is the bot should say, what is your email address, which we call an utter action, which is basically just an utterance, and we give it a name, which is ask email. The second option we have is, you could say, my email is something, which you call this change email story with an added address already. So here, the bot sees change email intent, but also, this is much harder with one hand than with two hands, but yeah. But also, it gets an entity. Those entities are written in curly brackets. It's basically JSON format for all those who are developers here. And you then, for example, say, oh, our email address is example@rasa.com. And that's it. Those are all the stories. Apart from the, what happens here, there's the a custom action that stores the email, which we have to write later down the road. And another utter action that confirms the email address. Yes. So by now, the bot only knows the stories, but the bot doesn't know actually what it should do, and it doesn't know about the intents and actions and all that. So it would tell you that it doesn't know these things. So we have to add the change email address intent as well as the email entity. We have so-called slots that are kept in a tracker state for the core. So this is the things the bot memorizes and remembers for the next action prediction. And we don't need to have this featureized, but basically this entity then gets stored in this tracker, and then we can get it afterwards. Templates are things the bot says for utter actions. So for example, when we say ask email, the bot should say, okay, what's the email? So maybe to go back to internationalization, you can do the same thing. You can just have a different language there and make it a different language part. What's your email? Yep. Lastly, for those utterances would be the confirm email, where we basically want to say, oh, yeah, okay. I saved your email as, and then we should want to actually give it the email we saved, and for that we also use those curly brackets again, and it just gets automatically filled from the tracker. And lastly, we have our custom action, which we need to tell the bot about, which we call action store email. Sorry, I'm really bad typing one hand. And then we just tell it again that those actions exist. Email. That is it for this domain and story file. Next up, we skip the implementation of the store email action for now, because we want to train the language model, because this is like a machine learning model that has to train in the background. So we're gonna just give it some data there, which could be, I want to change my email address. Well, change email. I want to change my email. Or you could say, my email is something. We again just going to use our example address here, because 2 examples is not enough. But like as you can see, tennis, I actually have some prepared data, which is just copy and pasting in there. And so yeah, as I said, 10 data points, and this is all we need to then basically train our bot, which you can use via makefile. So this is as easy as typing those 2 commands there, or 1 command actually. And this is now going to train in the background. We're going to implement our custom action. As it's going to be called action store email, and we have it to give it this name here as well. And what it should do is, we want to get our email address from our tracker, which is why we saved it. So this is a get slot. The slot is called email. And then we can save this. For saving this, the starter kit comes with a Google Drive service. So it gives you automatic access to a Google spreadsheet, where you just have to get the credentials for first and save them to an environment file. And we're going to instantiate this service. It automatically loads the credentials from the environment variable. And before saving it, we don't want to tell the user that something's happening before something crashes, so that we're actually trying to do something. There we can have this dispatcher, which is basically doing the interaction with the outside world. We can say, oh, we're now saving your email, and then actually do it. So there, the first thing, this is for this demo not the easiest because we need to put something in there, but we have one column which basically could be the name of the person. We don't know that because we didn't ask for that. And the second thing is the email address. This is our custom action. This is all we need. And yeah, we have now trained our language model. We now need to train our dialogue model, which we also do with this one line. I hope this works now and I didn't do anything wrong. I did some test runs before that, coming here again this morning, and I basically failed, but only 2 times. The other 3 times worked. And in the end, we still want to check whether we can actually, whether we did the right thing. For that, this is too small, sorry. For that, we're going to talk to the bot and just see whether it actually happened and learn what we wanted it to learn. This again takes some time to load up because there's just too much memory to load in. So basically, just to recap quickly before this starts up, we put some intent training data in the bot, trained the NLU model that uses TensorFlow and some fancy machine learning magic to learn embeddings of words to the intents we specified. And then we had our stories and our custom action, where we also learn a machine learning model that maps from dialogue states to the action, and then it just executes that. So the bot loaded up. I'll make this a little bit smaller again, bigger again, sorry. And we can talk to it. So we can say hi. The bot asks what we want to do. This is like, it knew that already. Then we say, oh, I want to change my email. Want to change my email. And it actually asks about your email address. We can say it is. My email address is nick@rasa.com. And it actually saves our email somewhere, at least it tells us to, that it's doing that. We can say thank you. And then we're back and it saved our email. We're going to check that in a second. Just one note, we can say it is rather than my email list or something, because it also knows the context and then can refer to that because we saved the tracker there. So this again is really small, but as you can see, this thing was actually empty before. I should have shown you, I guess. We can do another one, but you can do just another thing, which is present. You can try to just text it on this number, and we can look at it in the end, and I hope that we just see all of the email addresses on it. We're not going to send you anything you don't want to see. So it's just a nice trick to show you that this actually works. Yeah. I guess most of you have a ID number or a photo of it. Yes, no, maybe? Yes. We will get something.
Let's see Meetup on the
No, it is supposed to be a gimmick, and just to show people that you can build bots that actually do something quite quickly. So yeah, the final thoughts. We built a bot in I guess I haven't checked the time now, but I hope it was rather 5 minutes than 10 minutes. And it actually can do something. So building bots is hard because the design and all that is quite hard, but actually implementing them doesn't have to be. So 3 take-home thoughts, and then I also have 3 things that we still think that they're hard. There might be other things though. So we think that it is really important that you have methods that enable you to build bots with small data and little data sets. As you've seen, we had intent data set. Each intent only had 10 examples. You can easily come up with them yourself, or you can easily just ask 10 friends of yours to say this thing, and you have your data set for that. Also story-wise, we had I don't know, it was 20 lines of code, not even code to build your stories, and the bot does something and it works. We really believe in machine learning techniques, especially deep machine learning and deep learning techniques, because they help us to advance the state of language understanding and conversational AI. This, I say, also partially because we just published a blog post a few days ago where we actually showed that this new method of not using word vectors, pre-trained word vectors, but actually train the word vectors yourself on a task you care about helps a lot, especially on dataset languages where you don't have that many or that well-trained word vectors. Actually, yesterday was another blog post based on our blog post where someone trained a Bengali, as in someone in India trained a Bengali chatbot just using this method. And there are no word vectors, anything, it works. And lastly, as we've seen in the very beginning, flowcharts just doesn't work because they don't scale to real-world problems. To close with, here's some open challenges we think are important. One is, how do you handle out-of-vocabulary words? If you have a data set that covers everything and you can train on it, that's good, but real-life scenarios show us that that is not the case, and we need to come up with a way to deal with words that the bot and you haven't seen before, even though they have the same meaning. How do you tell the bot that this is actually the same? Then how do you do multi-language, entity recognition, and intent recognition? This ties in with the internationalization again. Currently there are barely any techniques doing that, and it's really, really hard. And lastly, how do you build dialogue models that you can combine? So basically, how do you build a plug-and-play system with different skills, saying I want to change my email, how is the weather, how is TFL doing today, and all those things. We don't have a solution for, and we don't know of any other solution where you can just basically build plug-and-play skills and potentially even distribute them to other people so that other people can start building bots even easier and faster. But as I said, we're constantly working on improving our models. We also have something in pipeline for making dialogue models channel-wise even better, but this will come up in a bit. Thanks for listening to me. There's my email if you have any questions, or just ask questions now or talk to me later.
Thank you for the live demo. Any questions?
It seems so.
Just now, maybe.
Everybody?
Hi, we're building a bot at the moment and getting into natural language. How effective can the machine learn just from saying something, labeling something as an intent without labeling the entities within it?
If you don't have entities and don't care about it, it works as fine. So we currently also treat it as 2 completely separate problems. We're thinking about it, and you can definitely use, for example, entity information to clarify the intent, but we're currently not doing it. And from our perspective and from our experience, it works like that as well for now.
Yeah, hi Nick. You said run local. When you mean local,
Local means
for training and then for executing.
both. But local, we don't mean don't use AWS or Google Cloud or something. It just means don't use a server you don't control. So with our software, you can just download it and implement it. Like basically, what we do is we develop locally and then deploy it somewhere on a server. That means still we have access to the server and we can control what happens on the server, so that you know that you own your data, you own all the traffic that goes through it and those things.
Got that. I really want to know if I can deploy on low-power local devices.
Yes, you can. I guess the usual disclaimer of machine learning models use not necessarily low memory. The models we are using are not that expensive. We actually built something on a Raspberry Pi that works on phones. I guess it depends on
I'm thinking of a Pi with a Matrix 1 board on or something like that.
That should work.
Okay, thanks.
Thank you. Any more?
I shall have a quick question.
So when your engine maps an utterance to an intent, can you control with what level of confidence you want that matching to happen at? So if I was building a bot and I really only wanted to match specific intents if they really did match, compared to just loosely matching, which seems to happen in some engines.
Because it's completely hackable, and it's also something we do internally for like projects for customers we implemented. You can easily just go into the library and hack around that and say, oh, I only want a confidence threshold of, I don't know, 70%. And if that's lower than that, you just don't care about it and go to a fallback intent or other things. I already did because the language understanding didn't work too well. In one case was basically overwriting the intent based on some rules I had because I know that they were failure cases.
Thank you so much. One more.
First off, applause to that previous question. Confidence in intervals, really want those. So I get your point about flowcharts being pretty crappy. But what would you recommend to designers such as myself to kind of explain how the bot should work? Because it's all well and good to kind of build straight into code, but when you start looking at larger teams and having non-programmers involved in the process, how should they be communicating what the end user experience should look like?
I don't know. No, like literally, for the projects I worked on, we still relied on flowcharts. But when it comes to the implementation, you can easily annotate a flowchart with like an asterisk and say, oh, here could also this and this and this happen, and then just go on a different page or zoom in and have those kind of more hierarchical blocks even. And yes, you need something to get this dialogue happening between designers and developers or business people and developers. There's no easy solution yet. I would be really happy to see if someone came up with one, but I think that's not easy to handle.